Hi all, today we will see a problem on arrays. So the problem is finding the largest sum contiguous array, contiguous subarray. Okay, so the problem is we need to find a maximum sum in a subarray and the subarray should be contiguous. So contiguous is nothing but the elements should be continuous. Like consider this array 1 minus 2 0 6 minus 6 minus 8 7 5. So here the maximum sum would be uh, 7 5 12. Here the maximum sum will be 12 and the subarray would be 7 5. So contiguous is nothing but it should be continuous and elements should be next to each other. It should not be like the subarray should not be broken like 1 minus 2 then 6 then 7. It should not be like that. The subarray should be continuous, so that's the contiguous subarray. And subarray can be the whole array itself. It can be of size 1 to size n. It can be of any size. So we need to find a largest sum which can be obtained from an array from contiguous subarray. So this is the problem. And the brute force algorithm would be straightforward. So we need to find the sum of each subarray from the array, and we need to compute the sum of all each subarray, and we need to find the maximum of it. So it can be easily done by two for loops. So the outer loop would be index I, and the inner loop would be starting from the outer loop will start from 0 to n, and in inner loop will start from I to n. So this will compute all the subarrays in the array. Sorry, j should go from I to I. So here we are iterating for adding all elements to find the sum. K equals I and k is less than or equal to j and k plus plus. Here we are having this, so we are initializing the sum as 0, and inside this k loop we are adding all the elements of the subarray. And for each subarray we are comparing the sum with the maximum sum. So if it is greater than the maximum sum, then that is the maximum sum. We are assigning the sum to the maximum sum. So initially we are uh, declaring a variable maxsum and initializing the value as int min, which is the possible minimum elements is supported by the compiler. So this is the brute force algorithm. So we are iterating from 0 to n in outer loop, and in inner loop we are iterating from I to I. sorry, in a loop we are iterating from I to n. So initially when I is 0, we are iterating from 0 to n. uh, so this is the brute force algorithm, and the time complex will be uh, big O of n cube. Why? Because we are having 3 loops with n iterations. So it will be big O of n cube, the time complexity will be, and the space complexity will be big O of 1, because we are not using any extra space. So it is big O of 1. Now we need to optimize this solution. This is not an optimal solution for this problem. So the optimal solution would be, uh, we can use an algorithm called Kadane's algorithm. So here the main idea is, so we are calculating sum for each element in the array, and if we find any negative sum, then we no need to carry forward that sum, because a sum with negative will reduce sum if we uh, sum that negative to any number. So we don't need to carry forward that negative sum. So if we find any negative value, negative sum, we will start from 0. So we will start from sum 0. So this is the main idea of the algorithm. So the basic algorithm is, we are finding the sum by adding each element in the array, and if we find it at some point, if we find any negative sum, then we won't carry forward that sum, and we will start from the next element, and we compare the sum with the maximum sum on each element, and if the sum is greater than the maximum, then we will assign this sum to the maximum. So this is the basic algorithm. So the observation is, if we find any sum less than 0, which is negative, then we don't need to carry forward that to the next element. So this is the basic idea. So the algorithm would be, for int I to n, for each element we are so initially we are declaring some uh, variable as max sum, and we are initializing with int min, and we are also initializing another variable which is sum, which is equals to 0. So for each element we are adding, we are finding sum by adding each element by iterating from 0 to nth index. So for each element we will find if sum is less than 0. If it is so, then we will reassign the sum to 0. Before that, we will compare this sum with int max, sorry, max sum, whether this sum is greater than max sum or not. If it is greater, then we are assigning this sum to max sum. And finally, this max sum will return the maximum sum contiguous subarray of any array. So this is the algorithm, an optimal algorithm for this largest sum contiguous subarray problem. So the basic idea is we are finding sum by adding the element by iterating through the array. As soon as we find any negative sum, we don't consider that for future computation of the sum. So instead, we will assign that sum to 0, and for each iteration, we will compare that sum with the max sum, and we will, if we find any sum is greater than max sum, then we will reassign that max sum to the sum. So this is, and finally, this max sum will return the maximum sum contiguous subarray of any array. So this is the optimal solution, which is nothing but Kadane's algorithm. So the time complexity of this algorithm would be big O of n, because we are iterating through the array only once, and space complexity also it is big O of n, because we are not using any extra space for this algorithm. So this is the most optimal solution for this problem. Thank you.